Let's break it down. Vibration is simply a back-and-forth movement. Think of your phone buzzing, a guitar string shaking, or a cat purring. It's everywhere, and it's how energy moves through objects. In machines, vibration is a natural result of moving parts. Engines, fans, drills, conveyor belts all have their own hum. This hum is the machine's signature, its healthy heartbeat. For example, a new electric motor has a smooth, barely there vibration when running well. We measure and record this baseline hum. It's our map of a healthy machine. Why does this matter? Because vibration is movement, and every machine with moving parts will vibrate. We don't want to eliminate vibration, we want to understand it. By learning the normal rhythm, we can spot when something changes. When the music changes, it's a warning something inside the machine needs attention. That's why knowing the baseline is so important. It's not about zero vibration, but about knowing what's normal. When you know the normal, you can catch problems early. Vibration is the language machines use to tell us how they're feeling. Listen closely, and you'll hear when something's off. This is the foundation of vibration analysis. It's about being proactive, not reactive. The better we understand vibration, the better we can care for our machines. And that's where the real value begins. Every machine has a normal vibration, a steady, predictable hum, but when something goes wrong, that hum changes. Abnormal vibrations are like a cough or limp in a person, a clear sign something's off. Maybe it's a new rattle, a grinding noise, or a stronger shake. These are the clues we look for. Imagine driving your car and suddenly hearing a new thump. That's an abnormal vibration. In factories, a change in vibration might mean a bearing is failing or a shaft is bent. The difference? Normal vibrations are low and steady. Abnormal ones are intense, unpredictable, or introduce new frequencies. Each fault creates a unique vibration fingerprint. By learning these fingerprints, we become machine detectives. We can pinpoint the problem like a cracked bearing or a misaligned shaft before it causes a breakdown. Vibration analysis turns chaos into clear, actionable information. It's about catching problems early, not just reacting to disasters. The machine is always talking, we just need to know how to listen. That's the power of understanding vibration. To see why vibration monitoring matters, let's look at how maintenance has evolved. First, there was reactive maintenance: wait for a breakdown, then fix it. Simple, but costly and risky. Next came preventive maintenance: replace parts on a schedule, like changing your car's oil every 5,000 miles. Better, but sometimes wasteful or too late. Enter predictive maintenance now. We use real data: vibration, temperature, oil analysis to predict failures before they happen. This lets us fix things only when needed, saving time and money. The most advanced step is proactive maintenance. Here we don't just fix what's broken, we find and eliminate the root cause. If a bearing fails, we ask why. Was it misalignment, poor lubrication? Proactive maintenance means longer-lasting, more reliable machines. Vibration monitoring is the key to this smarter, data-driven approach. It's about working smarter, not harder. The result? Fewer breakdowns, lower costs, and safer operations. That's the evolution of maintenance. So, how do we actually listen to machines? It starts with a sensor, usually an accelerometer, attached to the machine. This sensor feels the vibration and turns it into an electrical signal. The signal goes to a data collector, which digitizes it for analysis. Specialized software then breaks down the signal into its component frequencies using a fast Fourier transform, or FFT. This creates a spectrum, a graph showing which frequencies are present and how strong they are. Peaks in the spectrum reveal specific problems: misalignment, bearing faults, loose bolts. A trained analyst reads this graph like a doctor reads an EKG. The process turns raw vibration into a clear diagnosis. It's how we translate a machine's shakes into actionable insights. That's the magic of vibration condition monitoring. To run a VCM program, you need the right tools. First, the accelerometer, our sensitive ear for vibration. Next, the data collector, a handheld or installed device that gathers and stores vibration data. Then, powerful analysis software, where all the data comes together for review. The software flags problems, tracks trends, and helps prioritize repairs. But the most important tool? The trained analyst. Technology is great, but it takes human expertise to interpret the data and make smart decisions. Analysts spot patterns, diagnose faults, and recommend actions. The best gear is useless without skilled people. Together, these tools turn vibration into valuable information. That's how we keep machines running smoothly. Why invest in VCM? The payoffs are huge. First, it slashes unplanned downtime. No more surprise breakdowns shutting down your plant. Second, it cuts maintenance costs by fixing only what's needed, when it's needed. Early detection means small, cheap repairs instead of catastrophic failures. Third, your machines last longer, less stress, less wear, more years of reliable service. VCM also boosts safety by catching hazards before they become dangerous. And all this adds up to higher productivity and profits. Your plant runs smoother, produces more and wastes less. It's not just about fixing machines, it's about building a better business. VCM is an investment that pays for itself many times over. Listen to your machines and they'll reward you. That's the real value of vibration monitoring. Don't just react, predict, prevent, and prosper. VCM is getting smarter every day. Wireless sensors now monitor machines 24/7, sending data straight to the cloud. Artificial intelligence analyzes this flood of data, learning each machine's normal patterns. AI can spot tiny changes and flag issues long before a human would notice. The system might alert you. Pump 10B shows signs of lubrication failure, inspect within 48 hours. This is automated intelligent diagnostics in action. VCM data now integrates with company management systems. When a fault is detected, the system can create work orders, check spare parts, and schedule repairs automatically. It's a seamless loop from detection to correction. The future is about having an intelligent conversation with your machines. VCM isn't just listening, it's acting, predicting, and optimizing. Smarter machines mean smarter businesses. Welcome to the next era of maintenance.